Good afternoon, students. Good afternoon, students. Now we are going to discuss about the various methods in to handle the deadlocks. That means deadlock is nothing but here. Now we are discussing about the various methods. That means different methods here. Now we are discussing about various methods to handle deadlock. So this is what now we are discussing. Okay, here there is a deadlock in the sense what. So whatever in the previous class we are discussed about the four conditions. If the four conditions are simultaneously occurs, deadlock is occurred. Okay, now how the deadlock is handled. That means whenever the deadlock is occurred, no process finish their execution. So this is the problem. For that we can handle the deadlock. The deadlock is handled by using deadlock ignorance. Deadlock ignorance. And next, deadlock ignorance means, so whenever there is any chances are there for deadlock, that is ignored. So the next, deadlock prevention. So what is the deadlock prevention? That means prevention nothing but you can take care. So, that means to handle the deadlock. That means deadlock raakunda you can take some preventions. Okay. And third one is deadlock avoidance. Deadlock avoidance. Next, fourth one is deadlock detection and recovery. Deadlock detection and recovery. Deadlock detection and recovery. So this is various methods to handle deadlock: deadlock ignorance, deadlock prevention, deadlock avoidance, deadlock detection and recovery. So coming to this deadlock avoidance, when the deadlock is occurred, so any chances are to occur the deadlocks, so that can avoid. So how to avoid that one we are discussed afterwards. And coming to deadlock detection and recovery. So coming to this deadlock detection and recovery. So if even though we take care, that means deadlock is ignored. Okay, even the deadlock is occurred. So deadlock can prevented even the deadlock is occurred. Suppose sometimes it can avoid the deadlock even though deadlock is detected. So how the deadlock is identified, and after identifying the deadlock, how the deadlock is recovered. So these are the methods to handle the deadlock. Okay, so first we can discuss about what is the deadlock. Deadlock ignorance. Deadlock ignorance. What is the deadlock ignorance? So the name itself contains ignorance. What is the ignorance? So ignorance in the sense what? Here. So that is when the deadlock is occurred. So if two or more processes may try to access the resource at a time. So deadlock is occurred. That means two or more processes may try to occur may try to occur may try to uh, try to access, not occur, try to access the same resource. Deadlock is occurred, so deadlock occurs. Deadlock is occurs here. Suppose how this deadlock is occurred, that is, here suppose some P1 is some process, and here P2 is the another process. So this P1 try to access this R1. So this R1 is already used by this P2 process, and now this P2 process try to access this R2 resource. This is already held by P1. So in this case, here deadlock is occurred. Okay. Now, what is the ignorance? That is nothing but if any chance, that means some of the systems or some operating systems contain some code whenever the deadlock is occurred, that is ignored. So coming to the Windows operating system or Linux operating systems. So Windows and Linux operating systems. So these have some handle, that means whenever the deadlock is occurred, so these operating systems are ignored. Okay, so in the systems a deadlock is occurred, in this operating system deadlock is occurred rarely. That is, whenever the deadlock is occurred, that is operating system is hands, that is operating system is hands. That is, for example, here some printer is there. So this printer can access this process P1 as well as P2. So at a time this is not possible. So in this case the system is hanging. So that is at a time two processes are trying to access this printer. Now that system or printer is hanging. So in that case printer and system is hanging. So how it is handle? So then ఎలా హ్యాండిల్ చేస్తాం? So in that case just you can restart the system. So deadlock in ignorance in the sense, just restart the system. So restart your system. So now the problem is rectified. That is, problem is rectified. That is deadlock. Whenever the deadlock is there, automatically the system can hangs. So that deadlock that means restart your system. Now and is rectified. That means deadlock occurs, that is ignored. How it is possible? By restarting the system. So this is possible by restarting the system. Suppose here there is one problem. So every time system can hang it, and every time we can restart the system. So it is some of the and the CPU performance is decreasing. So that here this problem is rectified. For example, suppose operating system contains some code. So this contains some code. So that is the source code. That means how the operating system is booted and how the instructions are executed. That source code is, so whenever the input and output requests are there, how the resources are handled. That means it contains a source code as well as that is nothing but resource code also. Okay, so whenever to access this resource, so if any deadlock is there, so suppose to handle the deadlock, write some code to this resource code. Okay, so every time, that means every time the operating system load with this resource code, so every time this deadlock code is also, that means how to handle the deadlock, for that some code is there, that code is also every time repeated. That means it will give some burden, that is burden will increase on the CPU. That means may not be, that means deadlock occur chance unna lekapoyina kuda every time this code is executed, so that automatic burden will increase on the CPU. Burden will increase on the CPU. That means every time resource code is read, automatically this code is also repeated. So it will increase the burden on the CPU, so that automatically performance can decrease. That means time, whatever the time is spent for executing that one, that is increased, and capability of CPU is also increased. That means speed is also decreased, so that it is a concept. That means whenever we can add this code, it gives some burden. So here sometimes if there is no deadlock, even though this code is executed, so that just remove this one, just to simply ignore the that deadlock, that is possible directly restart. Here one advantage is there, that is system capability will increase, so operating system is efficient. So this is what ante ignore cheyadam valla em avutundi ante manaki, so operating system operating system, that means advantage for this deadlock ignorance is system capability will increase. So capability will increase and operating system is efficiently works. So this is what about the deadlock. What is that? Deadlock ignorance. And coming to the deadlock prevention. What is the deadlock prevention? Here deadlock prevention, nothing but, so first of all So deadlock prevention nothing but suppose deadlock prevention nothing but suppose here in this deadlock prevention how the deadlock that is prevented means, so how the deadlock is occurred we know that very well. So try to find the solution, that means deadlock prevention nothing but try to find the solution, try to find the solution before deadlock occurs, before deadlock occurs. Deadlock occur అయ్యే కంటే ముందే మనం ఏం చేస్తున్నాం, సొల్యూషన్స్ ని ఫైండ్ అవుట్ చేస్తున్నాం. అంటే మనకి డెడ్లాక్ రాకుండా ముందే we can find out some solutions. That means try to find the solution before deadlock occurs, before deadlock occurs. That is, so we know that the necessary conditions for deadlock, necessary conditions for deadlock are, so deadlock ki manaki necessary conditions enti, mutual exclusion and no preemption, mutual exclusion, no preemption and hold and wait, and fourth one is a circular wait. Out of that means all these four are, that means here these four conditions leads some deadlock. So if these four conditions are simultaneously satisfied, it leads some deadlock. Okay, so what is this deadlock prevention? So try to say is to make false of all these four conditions. So ikkada manaki deadlock prevention ela possible avutundi ante, so try to, that means whenever the deadlock is occurred means simultaneously these four conditions are satisfied. These four conditions are satisfied, then the deadlock is occurred. And so here deadlock prevention says that to make false, to make all these conditions are false, all these four conditions are false, then there is no deadlock. That means false, all conditions are false, otherwise or any one of, that means at least one, here all conditions are false, otherwise at least one, that means at least one, try to remove, make it as a false, that means any one of the condition. Ante ee four kanaka occur avute manaki deadlock vastundi. Okavela ee four false chesam anukondi, there is no deadlock, there is no deadlock. Ante సో ఈ డెడ్లాక్ అక్కర్ కాకుండా ముందే ఏం చేస్తున్నాం, మనం సొల్యూషన్స్ తీసుకుంటున్నాం. సో సొల్యూషన్స్ ఏంటి మనకి, దీస్ ఆర్ ద నెసెసరీ కండిషన్స్ ఫర్ డెడ్లాక్. సో దీస్ నెసెసరీ కండిషన్స్ అక్కర్ కాకుండా వీ కెన్ మేక్ సమ్ సొల్యూషన్స్ సో దట్ కెన్ మేక్ ఇట్ యాజ్ ఎ ఫాల్స్. సో ఆల్ ఫాల్స్, అదర్వైజ్ ఎనీ వన్ ఆఫ్ ద condition make it as a false or remove, then there is no deadlock. Okay, so this is what the deadlock situation. So this is what the deadlock prevention. So here only one thing you need to make all those conditions false. So how it is possible? That means to prevent the deadlock. So first one, to prevent deadlock. So first is mutual exclusion. That is make mutual exclusion is false. Mutual exclusion ni false cheyali. Mutual exclusion false nothing but what? So just to share the resources. That means ante non-shareable. Mutual exclusion nothing but non-shareable. That is non-shareable. Ante suppose for example printer undi. So printer is a non-shareable. At a time only one process can use this printer. At a time number of process. So this process can use this P1. So if it is released only, then this P2 is used. So at a time these two processes are not used. Okay, so that's why this printer is called as a non-shareable resource. So mutual exclusion and condition ella possible avutundi manaki non-shareable. That means if the printer use some resource that is not shareable, so there is nothing but mutual exclusion. Here just to share all the resources, but it possible only some cases. Okay, so that means ante ikkada non-shareable ante it is a non-shareable means mutual exclusion. Okala shareable annam anukondi, then meaning enti mutual exclusion is false. Mutual exclusion ni false. So if no sharing, no deadlock. And then sharing, and if sharing is there, so if there is no sharing, non-shareable means no shareable, so that deadlock is occurred. If if sharing is there, then no deadlock. So that is what deadlock occur అవ్వట్లేదు అంటే దాని మీనింగ్ ఏంటి? రిసోర్స్ ని షేర్ చేయాలి. రిసోర్స్ షేర్ చేస్తున్నామంటే దట్ ఈస్ నథింగ్ బట్ మ్యూచువల్ ఎక్స్క్లూజన్ అనేది ఫాల్స్ అవుతుంది. సో దిస్ ఈస్ వన్ వే టు prevent the deadlock. And next one is hold and wait. So next one is the no preemption. No preemption. What is this no preemption? That means no preemption ni false cheyali. So make it as false. No preemption ni false antunna. So otherwise no preemption false nothing but here that is nothing but preempt. No preemption false అనేది ఏంటి? Preempt. Okay, so how this preemption is possible? By using time quantum. By using time quantum method or time quantum. Ante here allocate some time quantum. That means each and every process is allocated with some time quantum. Within the time quantum only that process is executed. So if the process completely executed or not, that is not the concept. So only whatever the time quantum. For example, suppose here P1, P2 and so on, n number of processes are there. So time quantum is 10 milliseconds. Okay, this is 10 milliseconds. So for executing this P1 process, it requires some 20 milliseconds. For this, it requires some 80 milliseconds. For this, it requires 1000 milliseconds, like that. So only 10 milliseconds it is executed, and after that P2 is executed. Then next, like that. That means so time quantum complete ayanta varaku this P1 process is executed. Time quantum complete ayanta varaku emotundi this P1 process anedi execute avutundi. So time quantum complete kagane emotundi. So even though some bus time is left over, even though this process is preempted from the CPU. So ekkada nundi preempt avutundi, CPU nundi preempt avutundi. Then next another process is assigned to the CPU for execution. So this is what the no preemption concept is. So here time quantum method is required to each process. That means here some time allocate to each process to allocate the resource. And each and every process, that means to so here time is allocate to each process to access particular resource ని యాక్సెస్ చేసుకోవడానికి. సో ఈచ్ అండ్ ఎవ్రీ ప్రాసెస్ కి సమ్ టైం అనేది అలొకేట్ చేస్తున్నాం. ఏమవుతుంది మనకి? సో అంటే కంప్లీట్ గా మనకి ప్రాసెస్ సపోజ్ చూడండి, P1 ప్రాసెస్ ఈస్ దేర్, సపోజ్ టైం T1, సమ్ రిసోర్స్ R, అండ్ P2 ఈజ్ సమ్ ప్రాసెస్, T2 ఈజ్ సమ్ టైం సమ్ ప్రాసెస్. ఓకే, సో ఈ T1 టైం కంప్లీట్ కాగానే ఆటోమేటికల్లీ దిస్ రిసోర్స్ ఈజ్ రిలీజ్డ్ ఫ్రమ్ ద CPU. Released from this process. Okay, here that is P1 and T1. So P1 process assigns some time quantum. Within this time only this P1 process is executed or use this resource. So after completion of this time, so now this resource is released by P1 and it is used by some other process until this time quantum is completed. So the next other process is there. Now other processes enter into the CPU. So if there is only two processes, again this P1 is executed. So after completion of T1 milliseconds, again P2 is executed. So that no preemption. And sometime P1 is executed, sometime P2 is executed. So there is no concept of deadlock. So two processes are executing its that means two processes finish their execution. That means preemption prevent the deadlock. That is next one. And third necessary condition, that is hold and wait. How this is possible? Coming to this hold and wait, so make it as a false. Hold and wait is make it as false. That means try to do no hold and wait. Make it false means no hold and wait. Try to make it no hold and wait. అంటే ఏ ప్రాసెస్ కూడా ఒక రిసోర్స్ ని హోల్డ్ చేయట్లేదు, వెయిట్ చేయట్లేదు. సో ఎనీ ప్రాసెస్ కూడా రిసోర్స్ ని హోల్డ్ చేయట్లేదు, at the same time వెయిట్ చేయట్లేదు. That means all resources, that means R1 and so on, Rn resources are assigned to some process. That means try to no hold and wait, nothing but how it is possible. Try to give all the resources to processes. All the resources to processes before starts its execution. అంటే ఈ P1 starts అయ్యేకంటే ముందు, that is try to give all resources to process P before it starts. Okay, so this is what the deadlock concept. The next other one is, this is what the hold and wait. So next, fourth necessary condition is circular wait. So that means what circular wait? P1 process try to access some resource R1. So this is already used by P2. So this is already used by P2. So P2 process try to access R2 resource, that is already held by P3. Like this is what the P3 process try to access some resource R4. So this is already held by this is called as circular wait. So to remove this, there is no circular wait, then there is no deadlock. No circular wait, no deadlock. So how this circular wait is removed? So for this, here to remove the circular wait, just give the numbers to all the resources. So to remove circular wait, just give numbers to all resources. Just give numbers to all resources. Okay, so that is nothing but here for example, CPU is number 1 and printer number is 2, and for example some scanner number is 3, some other network devices like that. So these are the numbers. Okay, so that the process can request the resource in some order. So what is the usage of these numbers? That means process can use these resources in some, based on some number. Process use these resources in some order. That is nothing but, suppose for example P1 is some process. So here in the CPU P1 is executed. That means at a time only one process is executed inside the CPU. That means one is nothing but CPU. So here P1 process is executed, and coming to this P1 process is waiting for the scanner. So P1 process is waiting for scanner. So that here suppose some P2 process is there. Now this process P3 process is scanner is a resource. This is already include this P2. Okay, but in this case this is never assigned here. That means like this is not assigned here. So based on the timing, okay, based on the order, that means here P2, this is 1, resource 1 is already assigned to this P1, that is not assigned to here. So that it avoids a circular wait. And based on this numbering, some order is followed. So based on this number, so resource 3 is assigned to 2, but this is not assigned to here. Okay, so that means highest resource number is high, that is assigned to process P2, but resource number is low, that is not assigned to here. So that there is no circular wait. So it avoids some circular wait. So that to follow all these, okay, by using these all necessary conditions, that means by 4 conditions. So to make all these 4 conditions are false. four necessary conditions are false, then there is no deadlock. This is what the first concept, that is the first method, that is first two methods. One is the various deadlock ignorance and deadlock prevention. Deadlock ignorance and deadlock prevention. Okay. Thank you.